Okay, we are ready for lesson 4, 2.4, U.S. Traditional Multiplication, Part 1. We are going to be able to use traditional multiplication to multiply two-digit numbers by one-digit numbers. We're also going to be able to perform operations with multi-digit whole numbers and with decimals to the hundredths. Before we do, let's warm up. What you see here is you have 4 multiplication problems. I'd like you to pause the video, multiply them, and write your answers on a slate or on a piece of paper. You have 4 times 7, 7 times 10 to the second, 4 times 7 times 10 to the second, and 4 times 700. Pause the video now and try those out. All right, so for 4 times 7, we know that is 28. And we know from our previous learning that 7 times 10 to the second is 700, because this is just like saying 7 times 100. 4 times 7 times 10 to the second is 4 times 700, which is 2,800 or 2,800. And then 4 times 700, which is the exact same thing, is our 2,800. Some vocabulary that we need to know is partial products multiplication. Remember that this is a way in which the value of each digit in one factor is multiplied by the value of another digit and in the other factor. The final product is the sum of all these partial products. A similar method for multiplying mixed numbers. So partial product is where you take the different parts, the different place values, and multiply them. U.S. traditional multiplication, which is what we are focusing on today, is a multiplication method that produces partial sums based on multiplying the values of each digit starting from the right. So you'll take a look. Here's an example. We have 122 times 75. You can see that they did 5 times 2, which is 10. They put the 0 and they carried the 1. 5 times 2 is 10 again, but this time they had to add on that 1, which would be 11, carried the 1. 5 times 1 plus 1 was 6. And then they did the same thing for 7. But when they moved over a place value, they placed a 0 here because we're now in the tens place. So this is what we're focusing on today. And another method for multiplication is the area model. Area model is a model for multiplication problems in which the length and the width of a rectangle represent the factors and the area of the rectangle represents the product. This area model represents 3 times 5, and we did a lot of practice with this in the first unit. So I want you to solve this problem any way you like. You can use any multiplication method that you choose. Pause the video, solve it, and come back. So here I have a couple methods. I have traditional or the partial product setup, and I have the lattice setup. I'm going to use the lattice for this one, just as a reminder. So here we would take 4 times 9, which we know is 36. And then we would take 3 times 9, which we know is 27. Okay. And then we would add up these columns here, just like this, and get an answer of 306. Same thing over here. I would take 9 times 4, and I could say 36. And notice I'm carrying that 3 over. The 9 times 3 is 27, plus 3 would give me 30. And either way, any way that you do these multiplication, we still get the answer. So whatever method you used. This was just a nice little warm-up. So today we're going to explore some more with multiplication problems, so new strategy for solving with U.S. traditional multiplication. You're also going to learn how it relates to partial products multiplication. So we have 56 times 7, and you've been introduced to partial products in previous years in the Everyday Math program. So I want you to pause and take 56 times 7, but using partial products this time. Okay. So you can see here I have 56 times 7. I did my ones place first, so I did 6 times 7, which I know is 42. And then I moved over and I'm taking 50 times 7 because that 5 is in the tens place. And I can see that that's 350. And then I can add my two partial products together, giving me an answer of 392 for partial. On this screen, we see we're comparing the partial product to the area model. On the left, you have the partial product, and you can see the work that I just did 56 times 7. The first row is 7 times 6, and then 7 times 50, giving us an answer of 392. And then on the right is that area model. You can see that it's the same thing. They've split up 56. They've turned it into a 50, and they've turned it into a 6. And then they've got 7 times 50, which is 350, and then 7 times 6 was 42. And we know that we would add those two together. For U.S. traditional, using those same numbers, we're still doing 56 times 7. The first step you see here is multiplying the ones. So we're going to take 7 times 6, and that equals 42 ones, or as we know, 4 tens and 2 ones. You're going to write that 2 below the line in the ones column, and you're going to write the 4 above the tens column because that represents 42. This is like finding the partial product of 7 times 6 is 42, or in the area of the right part of the area model. Multiplying this tens is the second step. You're going to take 7 times 5 tens, which is 35 tens. Remember the 4 tens in step 1? Well, we need to add those. So you're going to take 35 tens plus 4 tens equals 39 tens in all. 39 tens equals 309 tens. You can see it's written down here. So you're going to write the 9 in the tens column and the 3 in the hundreds. This is like finding the partial product of 7 times 50, 350. Or in the area model, it's the left part of the area model, right here. So we can see that the final answer is 392, and it's the sum of the two partial products, multiplication work in the sum of the two areas. So we're going to do some more practice using U.S. traditional. We're only going to do a couple of these today. So I'm going to start off with looking at 26 times 4. So I'm going to rewrite this vertically. I'm going to do 26 times 4. And I'm going to start in my ones. I see that I have 6 ones times 4 ones, which is 24 ones, or 2 tens and 4 ones. Then I'm moving over. I'm now going to take my 4 times my 2, and I've got 4 ones times 2 tens, which is 8 tens, or 4 times the 2 tens, plus 2 more. So we have 8, 9, 10. So I'm going to write those down, and we get the answer of 104. Now, there is a way to check to see if our answer is reasonable. Remember in the previous lesson, we estimated, we rounded. So I would round. I know what 25 times 4 is, and 25 times 4 is 100 because I know 4 quarters. Oops. 4 quarters equals $1. Let me erase this. I messed up. And so I know 25 times 4 is 100. So I'm going to look at my estimation and my actual answer. I'm going to say, is it reasonable? Yeah, it's reasonable. It's right around the range. Let's do 72 times 7. So I'm going to rewrite 72 times 7. So I'm going to do 7 times 2. 7 ones times 2 ones is 14. We're going to carry that 10. 7 times 7 is 49, plus 1 more would be 50, giving us an answer of 504. When solving problems, it's important to check whether your answers make sense. So just like I did in that 26 times 4, especially when it's a new strategy, okay? So they're asking us, how can we check? Well, what I did in the previous one, remember I estimated here. We could also check our work by solving the multiplication problems in the other ways that we already know. Do it in US traditional first, and then maybe check it in lattice. Check it in partial. Okay? And always asking yourself, do my answers make sense? So remember, you can solve the problem again by using the different method, and you can also estimate like we showed. So what I'd like you to do is turn to page 48 in your math journal, and remember to all the questions, stop and make sure that your answers are making sense. So you've got 1 is 23 times 6, 2 is 76 times 5. What we want you to do is solve at least one of these using US traditional. You don't have to do both. You can, but just at least try one of them in US traditional. And then choose problem 1 or 2 and explain how you checked your work. Explain how you checked to make sure that your answer was correct. 4 and 5, it gives you a list of steps that you need to do. Write a number model with a symbol of the unknown. Solve the problem using US traditional multiplication for at least one of them. So you've got 2 here. Solve it for at least one of them, and then write your answer. So you see, these are more of word stories. Sorry, lost my train of thought there. Paula has 7 decks of cards. Each deck of cards has 52 cards in it. How many cards does she have in all? So you see the model they gave you here is 52 times 7 equals C. 5, a bush is 21 inches tall. A tree is 5 times as tall as the bush. How tall is your tree? 6, a fence has 45 sections. Each section is 6 meters long. How long is the fence? And 7, an apartment building is 9 apartments on each floor. There are 43 floors. How many apartments are in that building? So pause the video, do these 7 problems, and then come back and check your work. All right, back to 1 and 2. Number 1, you should have gotten the answer of 138, and you could have solved that multiple ways to check your work. And number 2, 76 times 5 is 380. On number 3, you should have been able to just explain how you solved that. Number 4 and 5. Number 4, you should have seen that Paula has 364 cards, and the tree is 105 inches tall. And finally, 6 and 7. For number 6, you should see that the fence is 270 meters long, and the apartment building has 387 apartments. I'm going to solve number 7 for you here just as a wrap up. We see that we have 43 times 9, so we should have written 43 times 9. And I know they've got 9 ones times 3 ones, which is 27. So I'm going to write my 7 and carry my 2. Then 9 times 4, we said 36, plus 2 more is 38. So I'm going to write down that 38 right here. And we get a total answer of 387. And that is what they told us we should have been getting. So this was just part 1. We are actually going to have multiple parts of US traditional. Again, we were working on 2-digit by 1-digit numbers. As you can probably guess, we're going to move forward to do multiple digits times multiple digits. We're doing this, remember, because multiplying multi-digit whole numbers fluently using a standard algorithm or algorithmic approach is one of our standards. So now that you've watched the video, you can come back to it to look at examples if you need it, but now it's time to move on to your independent work.